Okay, so we started section 2.8. It deals with distance and midpoint formulas and circles. I gave you the distance formula. I gave you the midpoint formula. And I gave you the two different forms that a circle can be in. And we are actually ready for example 1 there. Example 1 says, find the distance. Find the distance between each pair of points. Okay, we want to use simplified form and then round to 2 decimal places. Okay? The simplified form is if I have something like the square root of 20, they want you to write that as 2 square roots of 5 to start with, then give the decimal approximation. Okay? So A, I have the points 0, 0. And 3, -4. Okay, so I'm going to use my distance formula. Guys, I will not give you a formula sheet. This is college algebra, 13, 14. You will eventually probably get into calculus or even in pre-cal and trig if you have to take those, and they don't give you a formula sheet. So that's why we don't give a formula sheet in 13, 14. Even if you're not going on, we don't because you possibly could, and they don't let you have a formula sheet there. So you will need to know the distance formula. I know that is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? And of course, they did give me x1, y1 and x2, y2. Okay, I'm going to plug those in. That's all I do. So I've got D equals the square root of 3 minus 0 squared plus -4 minus 0 squared. That's going to give me the distance is equaling 9 plus 16. And D will equal the square root of 25. This one turned out nice. And we know that is 5. Okay? Guys, where that comes from and how I told you that's like the Pythagorean theorem. All it is the Pythagorean theorem. If I were to plot those points, I've got 0, 0, and I have the point 3, -4. Okay? Okay, and I'm needing to know the distance here. This is what I'm needing to know. Okay, and what we have with Pythagorean theorem, we would turn this into a right triangle. And so it would have legs of length 4 and 3. Okay, and we would use a squared plus b squared equals c squared. Because this is C, the hypotenuse is always C. The legs are A and B, okay? Hypotenuse sits across from the 90-degree angle. So we would say, okay, I can find C because I can say 4 squared plus 3 squared is going to equal C squared. That would give me 16 plus the 9 equals C squared. It's 25 equals C squared. And that would give me 5 equals C. Now, some of you are going, we didn't put that plus minus there. When we're dealing with a distance, can a distance be negative? No. Okay, it's a lot like the absolute value. When we define absolute value, we go, okay, that's the distance between 0 and another number on the number line. Okay, and since it's a distance, things come back positive. Well, when I'm asking you the distance between 2 points, I can't have a negative. So when I take that square root of 25, yes, usually when I force a root, I put plus or minus, because negative 5 squared will be 25. But since I'm talking about a distance, I can only use the positive, okay? But that's where it comes from. You do not have to do the problems like that. You don't have to do the extra part with the Pythagorean theorem on there. I do it to show you where it comes from. I'm also a person that does not like to recommend memorizing things. Most things in math can be derived. You have to move some stuff around, but we can derive our answer. Like we could have gotten the answer, the distance was 5, without the distance formula. We could have done it by Pythagorean theorem, and that's what I show you right there. So if you don't remember what the distance formula is, you're not out of luck. You can still find it. You can still get an answer. Okay? B says 0, -3, and 4, 1. Okay? I've got my distance formula again. That's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? Of course, they gave me the points x1, y1, x2, y2. I'm ready just to plug that in. That's going to be the square root of 4 minus 0 squared plus 1 minus a -3 squared. Okay, that's going to give me D equals the square root of 16 plus 16. And that is the square root of 32. This is one of those where they want you to simplify it. Okay, so square root of 32, this is one where I go, okay, I need to think about the perfect squares. And what perfect square will divide into 32? 16, of course. So this breaks down into the square root of 16 times 2, which square root of 16 is 4. Square root of 2 stays inside. So I get my distance is 4 square roots of 2. And then I need the decimal approximation of that. If you put that in your calculator, I'll use the calculator that's on the iPad because it is scientific, but you'll have your handy dandy little calculator there. If I put in 2 square root, okay, times 4, gives me 5.66. It does say round to 2 decimal places. So that should give me 5.66. Okay. And that is B. We do have a C because they want to make our lives a little more complicated. They give me the 0.2 square root of 3, square root 6, and negative square root 3, 5 square root of 6. Okay? Once again, I write down the distance formula. Guys, these radicals are just numbers, okay? That's 2 times a number that's a little bit, square root of 3 is a little less than 4, or it's a little less than 2. Because think about what is the square root of 4? Well, it's 2, okay? So that means the square root of 3 is going to be less than that. So it's 1 something. Square root of 6 is less than the square root of 9, which is 3. But more than the square root of 4, which is 2. So square root of 6 is some number between 2 and 3, okay? They're numbers too. That's why we can plug them in there. x1, y1, x2, y2. I know that my formula says x2 minus x1 squared plus y2 minus y1 squared. Guys, I don't write that for my benefit. I know what the distance formula is. I've been writing the distance formula since I was 13, so for 34 years. I write it so that you write it, and the more you write it, the easier it is for you to remember, okay? So I've got the distance equals the square root of negative square root 3 minus 2 square root 3 squared plus 5 square root 6 minus square root 6 squared. Okay? Negative square root 3 minus 2 square root 3, that's going to give me negative 3 square root of 3 squared plus 4 square root of 6 squared. Okay? Negative 3 square root of 3 squared is really 9 because I square that negative 3. Now, when I square the square root of 3, what do I get? 3. Remember, when you square a square root, what happens? Inside falls out. Those are inverses of each other, so whatever's on the inside comes out. And that's going to give me 9 times 3 plus 16 times 6. 4 squared is 16. Square root of 6 squared is 6. Okay? That's going to wind up giving me square root of 27 plus 6 times 6 is 36, carry 3, so 96. Square root of 27 plus 96. That's going to give me the square root of 123, I believe. Okay. This is where we go, okay, could a perfect square go in there? I start out thinking about what's going to divide into 123. Nicely divide in there. 2 won't because it's not even, but 3 will. This turns into 3 times 41, but 41 is prime, so nothing can happen to the square root of 123. So I get D equals the square root of 123, which is approximately, if I go over here and I say 123 square root 11.09. Okay, and like I said, you can put that in your TI-30 excess multi-view. Isn't that what it's called? TI-30 excess, maybe multi-view, okay? I don't know. Yes. Yeah, whichever one you have. Well, you can put that in there. Okay. That is example 1. We're on example 2. Example 2 is going to deal with the midpoint formula. It says find the midpoint of each line segment, sorry. We even had the conversation about you can't find the midpoint of a line, with the given endpoints. Okay, so A is 6, 8, and 2, 4. Okay, that midpoint formula is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, like I said, you do need to know that. That means I'm going to get pretty much, guys, you're just averaging the x's and averaging the y's, because you want the midpoint, so it's going to be a point, right? You got to have an x and you got to have a y. So I've got 6 plus 2 divided by 2, and 8 plus 4 divided by 2. That's going to give me 8 over 2 and 12 over 2, which then, of course, gives me the 0.4, comma 6. That's the midpoint between those 2 points. Okay. If we want to look at an image of that, I have the point 68. Of course, I didn't do enough space. Do I really want to look at an image of that? 1, 2, 3, 4, 5, 6, 7, 8, 0. 1, 2, 3, 4, 5, 6. Okay, so I have 6, 8 is one of the points. And then I have 2, 3, 4 as the other endpoint of that line segment. And we just found that the midpoint is 4, 6. So 2, 3, 4. 1, 2, 3, 4, 5, 6. And sure enough, there it is. Graphically, that's what that looks like. You've now found the midpoint algebraically and graphically. That is A, B. Same directions. We're going to find the midpoint of the line segment. This time, they give us some fractions, -2/5 and 7/15. And -2/5 and -4/15. Some of you can tell in your head what kind of line this is. Okay? It's saying X is, we go -2/5, positive 7/15, and then -2/5, -4/15. Where did we go each time? What's our X each time? -2/5. And if X is the same each time, then I'm going to get a vertical line. Okay? But we've got our midpoint here. Formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay? I'm going to plug those in. I've got an x1, y1 and an x2, y2. All right, that's going to give me, we're going to plug those in. Give me just a second. Fixing it. There we go. So I should have, I'm going to make this a little bigger here. I've got -2/5 plus -2/5 all over 2. And y1 is 7/15. Y2 is plus a -4/15. And that's all over 2. Okay? They did keep the fractions nice there because they have common denominators. So -2/5 and -2/5 is -4/5 over 2. And then that's 3/15 over 2. Guys, when I'm dividing by 2, I'm really multiplying times a half. Keep, change, flip. Even if it's not been that long since you've been in school, I promise you your math teachers, middle school and high school math teachers still talked about keep, change, flip. That one I don't think will ever die. So this is really -4/5 times 1/2, which gives me -4/10. And 3/15 divided by 2 is 3/15 times a half, so that's 3/30. And if I simplify that, that's going to give me what? -2/5. And we knew that we were going to get the x to be -2/5. And 3/30 is 1/10. Your multi-view, if you have this one, the multi-view, you can actually set it up as a fraction in there. If you push the N over D button, if you see the second button and you go down, I don't know if yours will, Josh. But if you go like 2 underneath the second button and then 1 over, it says N over D, numerator over denominator, then it'll make a stackable fraction for you that you can put in there, and it'll produce 1 back instead of a decimal. Okay? So we get the answer of -2/5 1/10 for B. Yep. And C. C, we're still finding the midpoint. I've got the square root of 18 with -4 and square root 2 with +4. okay? So I have the midpoint formula, of course, and I've got x1 plus x2 divided by 2 and y1 plus y2 divided by 2, okay? That's going to give me square root of 18 plus square root of 2 all over 2 and negative 4 plus 4 all over 2. Well, half of this is very nice, okay, because that negative 4 plus 4 over 2, of course, that's going to give me 0. Guys, the square root of 18 plus the square root of 2 turns out nice. You just have to simplify the square root of 18. I'm going to do that over here. If I got the square root of 18, the perfect square that goes with it is 9, right? 9 times 2, so this is really the square root of 9 times 2, which square root of 9 is 3, square root of 2. So that turns back friendly. That's going to give me 3 square roots of 2 plus the square root of 2 divided by 2 all over 0, well, not all over, with 0. Okay, because negative 4 plus 4 is 0 divided by 2, okay? 3 square roots of 2 plus the square root of 2 is going to give me 4 square, good. 4 root 2, good. 4 square root 2 over 2. And Iana probably does say 4 root 2. I didn't think of that till just now. And it reminded me, when I said it, it reminded me of my professors I had in math, and I'm like, Iana does, she says 4 root 2, not square root. She doesn't, she just says 4 root 2. They all did. They say it's shorter, 4 root 2, and then instead of saying 0, it's often not. They use not. Some did.
Yeah, some teachers do.
Some do. Probably if they're older, they did. Yeah. So 4 square root of 2 divided by 2, that is really 2 square roots of 2. Guys, the 2 in the denominator can go with it can divide into the 4. It cannot divide into the square root, okay? Because in order to divide into the square root, you've got to be in a square root. Outside goes with outside, inside goes with inside, okay? So I get 2 square root 2, 0. Okay, good job. All right, let's move on to our circles. Yeah, that's not the funnest. I know. It'll be all right. Example 3. We want to write the standard form of the equation of the circle with the given center and radius. Okay? Write the standard form of the equation of the circle with the given center and radius. So we know that the standard form, and you can look back over there because you just learned it. Standard form is x minus h squared plus y minus k squared equals r squared. HK is the center and r is the radius. Okay? Question A gives a center of negative 3, 5 with a radius of 3. Okay, and guys, all they want you to do is write it in standard form. This is a pretty nice one. Okay, if I've got the center is negative 3, 5, I know that's an HK. If I have a radius equals 3, that's my R equals 3. So all I have to do is plug it into my formula, into the standard form. And clean it up a little if needed. And we got to do a little cleaning here. So this is going to become x minus -3 squared plus y minus 5 squared equals 3 squared. All I did was plug in h, k, and r, okay? That's going to give me x plus 3 squared plus y minus 5 squared equals 9. Okay? And that's what it asked me to do. Write the standard form of the equation of the circle. Okay? You're good on that one. Let's do B. B's just as easy. I can squeeze B in here. That's what I always tell myself, don't I? Then it never works out good. We have a center of -2, -4 with a radius of, that got chopped off. Oh, I know what it is, 5. Let me look at what my answer was, and I can tell you what R was. Okay, so they gave me an H, not an X. They gave me an H, they gave me a K, and they gave me an R. I'm going to plug it into x minus h squared plus y minus k squared equals r squared. Okay, so that's going to give me x minus -2 squared. I probably should put the parentheses around there so you can see it. Plus y minus -4 squared equals 5 squared. Let me write that a little nicer. There we go. Okay. X minus -2 gives me x plus 2 squared plus y plus 4 squared equals 25. Okay, and that's your answer. So those are friendly. Those are nice. They're not too bad at all. Let's look at some that aren't the friendliest. This one's not as unfriendly as it gets. Example 4 says, give the center and radius of the circle described. Give the center and radius of the circle described. Okay, use the graph to identify the relations, domain, and range. Okay. A, I have x plus 1 squared plus y minus 4 squared equals 25. Okay, so they want me to give the center. They want me to give the radius. They want, it says use the graph to identify the relations, domain, and range. So we need to, that means we also have to graph it, okay? Which, that's not too bad. So the first thing we need to do is we need to figure out what the center and the radius are. Okay? Now we're going to match that up with our standard form, which is x minus h squared plus y minus k squared equals equals r squared, sorry, equals r squared. Well, probably the easiest one for you to identify there is r squared, right? And we can find out what the what r is. So I know that r squared equals 25. If I take the square root of both sides, now yes, I should put the plus minus there, but am I going to list -5 as a radius? No, because it's a measurement. Okay, so it's a distance, it's a measurement. It's the distance from the center of the circle to the edge of the circle. Okay, So we only have to list positive 5. So I know my radius is 5. It's a measurement. It can't be negative. Okay, so let's think about how we're going to get the center, the HK. Guys, that negative is already pre-built into the standard form. So what we have to do is when the easiest way for you to remember it is when we write the center, use opposite signs. Because if you'll remember or look back on example 3, what did I do? I would plug in x minus negative 4, close parentheses squared. And then y minus negative 2, close parentheses squared. So there was like a minus a negative or minus just the positive number. It winds up being the opposite sign. So my center is not going to be a positive 1, negative 4. My center is going to be who? Negative 1. Yeah, negative 1, positive 4. So if you need to, just think of it like that, use an opposite sign when we write the center. Okay? So that gave me my center, that gave me my radius. I'm going to need to find the domain and range. It told me of that circle once I graph it. So that does mean I need to graph it. Let's see, I've got a center at 1, negative 4 with a radius of 5. Okay. So I'm going to go, that's probably not a negative 1. I have a radius of 5. Oh, okay. I have to make that bigger. Okay, so I have a center of negative 1, positive 4. That's all right. We'll keep it there. Okay, so negative 1, positive 4. 1, 2, 3, 4. All right, there's my center. And it tells me I have a radius of 5. So the easiest way for you guys to do this is you're going to go in all 4 directions. I hate to say it, north, south, east, and west, or left, right, top, bottom, top, okay? We're going to go how far? 5, because the radius is 5. That radius gives me the distance from the center to the outer edge of the circle. So I'm going to go up 5, 1, 2, 3, 4, 5. I'm going to make a dot. That point lies on the outside of the circle. I'm going to go right 5. 1, 2, 3, 4, 5. I'm going to go left 5. 1, 2, 3, 4, 5. And then I'm going to go down 5. 1, 2, 3, 4, 5. Those 4 points are the edge of your circle. Now, I'll say good luck on drawing your circle with those 4 points. Mine never turns out nicely. It doesn't matter how I twist my iPad around. Look, see, I missed the whole, so we just make the point bigger. Okay, so you actually could label your domain and range. You could find it if you can see it in your head without drawing the circle. It's just easier if we draw the circle, okay? So that means this point up here at the top, let's label the points. That means this point at the top is at negative 1. 1, 2, 3, 4, or well, what was I at? What did I start at? 4 plus 5 is 9. That should be negative 1, 9. Okay, this should be negative 1, right? This one is going to be what? 1, 2, 3, 4. 1, 2, 3, 4. 4, 4. Yep. And then this one's going to be at 1, negative 2, negative 3, negative 4, negative 5, negative 6. negative 6. What was that? 1, 2, 3, 4. 4? Okay? And if you'll notice, that makes sense. What's the distance between negative 6 and 4? It's 10 units. That's your diameter of the circle. What's the distance between 9 and negative 1? It's 10 units. Okay? So that means you graphed it right. That's what that's saying. Domain are your x's, right? Domain's x. Where does, what x value, what's my leftmost x value?
Negative 6.
Negative 6. What's my rightmost x value?
4.
Positive 4. Okay? And then my range, what's my lowest y value?
Negative 1.
Negative 1. And what's my highest y value? 9. And you have listed domain and range. All that's saying is we only see that circle. That circle's present between negative 6 and 4 on the x value, and then between negative 1 and 9 on the y value. Okay? All right, that was 4. Oh, that was, I put A like there was more, but there's no more. All right, let's look at example 5. Okay, example 5. I have give the center. Well, it's the same direction, so we should have called that B. Give the center and radius. We want to graph it. Oh, I was getting tired of writing notes, evidently. And give the domain and range, because I didn't write many words out there. Okay? They give me x squared plus y squared equals 9. This one's actually a lot friendlier than it looks. Guys, if you're given something and we don't have the parentheses x minus something or x plus something or y minus something, y plus something, guys, that center's at 0, 0. Okay? Because let's think about it. If I had x minus 0 squared plus y minus 0 squared equals, what's r here? Can you tell me what r is? 3. 3 squared. Guys, what's x minus 0? Just x. So that turned into just x squared. And that turned into just y squared equals 9. Well, x squared is x squared. Y squared is y squared equals 9. So your center is at 0, 0. 0, 0. Your radius is 3. Because the square root of 9, r squared equals 9. R equals the square root of 9. And since it's positive, it will be 3. Okay? If I do my domain and range, we'll go ahead and graph it. This isn't a very large circle. It's pretty nice. If I gave myself enough room, I'll probably have to make my intervals a little smaller. Okay, so I'm gonna cut them in half. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I have a center at 0, 0. Let me blow it up for y'all. I have a center at 0, 0. Then I'm going to, if my radius is 3, I'll go up 3, 1, 2, 3. I'll go right 3, 1, 2, 3. And I'll go left 3, 1, 2, 3. And I'll go down 3, 1, 2, 3. And then it breaks the mold there because the circle's going to be so great. Actually, that's not too bad looking. Better than the last one I did. Okay, so my domain, I know that this point right here is 0, positive 3. This point is 3, 0. This point is 0, negative 3. And this point is -3, 0. Guys, it's easier for you to do domain and range if you'll list those points. Okay? So my X, I'm looking from left to right, or start to stop. Where does it start on the X value? -3. And where does it stop on the X value?
+3.
Yep. And my range, what's the bottom?
-3.
Yep. And what's my top? +3. Same, right? Get the same thing? Good. That's example 5. Do we need to do, oh, yeah, we got to do 6. Example 6. Because I promised you that there would be questions where we went from general form to standard form, and what do we have to do? Complete the square. That's 6 and 7. Okay? Okay, yeah, battery's going to make it till then. Example 6, I forgot to plug in. I teach night class on Monday nights and Thursday nights. Monday night class goes till 8:40. This is statistics class. It's an hour drive home. I don't get home till nearly 10 because stats always runs late because I got more to teach. Anyway, 10 o'clock when I get home, I didn't plug the iPad in last night, so I got up this morning and it was on 17%. Yeah, so I got it plugged in. I got you up to like 33 before I got in here. But yeah, we're down to 15. But it'll make it through 6 and 7. And I'll plug it up. I'll use that thing for contemporary if I need to today. I don't need to do a... I don't need... Who is that? I don't even know who that person is. Give the center... Oh, yeah, that's from the other school that I teach at. I teach online, and I teach online down in Baytown at Lee College. And so I never see those students. You know, I never put a face to a name. They're just random names that pop up, and somebody's going, Unit 2 exam, and I'm like, I don't recognize that name of people here at TJC that's taking Unit 2 exam. Well, no, this person lives down in Baytown, 4 hours away. I was like, oh yeah, they're testing this week too. Give the center and radius. They're going to tell me that they're using an iPad and they can't use Honor Lock on an iPad. I already know where that's going. Graph and give the domain and range. Oh, no. Give the center, and radius, domain and range. Oh, I was real tired here when I wrote this years ago. I wrote this lesson like 5 years ago. Nearly 6. And then write it in standard form. Okay, we want to give the center and the radius. We want to graph it. We want to find the domain and range, and we want to write it in standard form. That means it's in general form. And they give us x squared plus y squared plus 6x plus 4y plus 9 equals 0. Okay, so let's go through the steps of what we need to do. First thing you're going to do is you're going to put the x's, and that shouldn't have an apostrophe. It should just be x's, but it looks weird. Together, put the x's side by side, we'll say. And y's side by side. Then we're going to also move the constant. Okay? So, I'm going to rewrite. I'm doing a rewrite. That's what I'm doing. I'm going to turn this into x squared plus 6x. I want those together. Plus y squared plus 4y. Okay? Equals -9. Move that 9 to the other side. We got to get a radius over there, right? So we got to start doing that. Now, we need to complete the square. On the x's and y's. Okay? So I'm going to take this x squared plus 6x, and I'm going to complete the square. And then I'm going to take y squared plus 4y, and I'm going to complete the square. Okay? So I'm going to take my, and if you'll remember, we did completing the square back in 1-5. I think it was 1-5. Yeah, it was 1-5. 1-5, 1-6. I think it was 1-5. Okay, so I take that 6. I'm going to multiply it times 1/2. That gives me 3. Remember, that's the one that I put in the cloud. Then I go 3 squared, and that gives me 9. Okay? So I've got x squared plus 6x plus 9. Okay, I'm going to leave some room for my y friends there. I've got my -9. Guys, what I did to one side, what did I do to the left-hand side so far? I added a 9, so I've got to add a 9 on the other side with my other friend. Okay? Now I'm going to complete the square on y squared plus 4y. So I'm going to say 4 times the half. It's going to give me 2. Put that in my cloud. And then I'm going to say 2 squared equals 4. Okay? So now I've got my plus y squared plus 4y plus 4. Now I added 4 to the left-hand side, so I got to add 4 to the right-hand side. Okay? Now you're ready to finish completing the square. You can factor your x's, and now factor your y's. Then add up the -9, 9, and 4. So x squared plus 6x plus 9, I'm looking for what multiplies to be 9, adds to be 6. Remember, that's why we put that in the cloud. That's really x plus 3 times x plus 3. Guys, if you know to write that on as x plus 3 squared, go ahead. That's where we're going. I'm just working it out because it's been a little bit since we did completing the square. Y squared plus 4y plus 4 is going to be y plus 2 times y plus 2. And that's going to give me a positive 4. Okay? That, of course, becomes x plus 3 squared plus y plus 2 squared equals 4. Okay, there's one of your answers right there. That's standard form. It's the last one. Okay, now I can give the center. Okay, if I'm looking for the center, I told you change the signs, opposite signs, right? So center's not going to be at 3, 2. It's going to be at -3, -2. Okay, I can find that radius now. I know that r squared equals 4. So that means r is going to equal 2 because r equals plus or minus square root of 4. And then I need a positive. So I got a radius of 2. And now all that's left is the graph, the domain, and the range. Okay? Okay, so let's see. Okay, so radius isn't too bad. Radius is 2. I should be able to fit it in there. That's what I always worry about. I draw your coordinate plane, and it's like, oh, I didn't give myself enough room. Center is at -3, -2, 1, 2, 3, 1, 2. Then I'm going to go up 2. Got my low battery message. I'm going to go right 2. I'm going to go left 2. And I'm going to go down 2. That was not a good circle. It's a little lopsided there. Oh, well. Okay, so I'm going to list those points. I've got a point at -3, 0. I've got a point at -3, what is that, -4? Should be, because radius times 2 is 4. Got a point at -1, -2. And then I have a point at 1, 2, 3, 4, 5, -5, -2. Okay. So on that domain, what's my, where do I start on my x's? Good. And where do I stop on my x's?
-1.
Good. My range, what's my bottom? -4. And then what's my top? 0. Good. Okay. So let's see if we wrote them all. We've got center, radius. Yep. Center, radius. We got the graph. We got domain. We got range. And we got our standard form. Good job. That was example 6. Let's see if iPad will make it. Oh, we're on 9%. It'll make it. We got one more. We got one more, and it's to complete the square. So I want to give you a fair shot on completing the square. Complete the square and write the given equation in standard form. Then give the center and radius of the circle and graph the equation. Hey, no domain and range this time. Woohoo! So we're going to complete the square. I'm going to shorten all those words I said. Standard form. Okay. We want a center. And we want a radius. I'll be honest, guys, I like circles. They're not complex. Even though they seem complex, they're really not. They're very tangible. They're things we can touch, and they're reasoning. Yeah. But we don't do too much with them. Remember that standard form is x minus h squared plus y minus k squared equals r squared. That tells me I need a center and I need a radius. Okay? And they have given me x squared plus y squared minus 4x minus 8y minus 16 equals 0. Okay? So we start off, put the 2 x's beside one another, put the 2 y's beside one another, move the 16 to the other side. X squared minus 4x plus y squared minus 8y equals 16. Okay, I'm going to complete the square on the x's, then complete the square on the y's. Remember to put your new friends on the other side too. So -4 times the half gives me -2. You can bubble that. -2 squared gives me a +4. So I have x squared minus 4x plus 4. Okay, I'm going to leave some space for my y friends. I got 16. I got to add my 4 over there with the 16. Okay. Let's take care of our y friends. -8 times a half gives me -4. Bubble that. -4 squared gives me 16. We're going to add 16 on to the y's. So plus y squared minus 8y plus 16. And then I got to add 16 over there. Okay. Now I'm ready to complete the square there. I'm ready to factor. I know it's going to turn into a square, and I'm out of room. So I'm going to put x, who's in my bubble, -2, minus 2 squared, plus y, who's in my bubble, -4 squared, equals 16 plus 4 is 20. 20 plus 16 is 36. You are now in standard form, and they were friendly to you. Okay, what's my center going to be?
-2.
Change the sign? +2, 4? Yeah. Remember when we deal with center of a circle, it's opposite sign. My radius is going to be 6. Good. Because r squared equals 36, which means r will equal 6. Did it tell me to graph it? It did not tell me to graph it. Good job. There you go. And we made it. I will pull up the review on, didn't Willow come in? Did Willow go away? Oh, didn't say Willow go away. Okay.
She had a text message as well.
Okay, thank you.